This question is from GATE 2012 Mechanical Engineering paper, question number 9. A solid disk of radius small r rolls without slipping on a horizontal floor with angular velocity omega and angular acceleration alpha. The magnitude of the acceleration of the point of contact on the disk is dash. Let's see. Let this be the surface on which a disk of circular cross section with radius r is rolling at angular velocity omega and angular acceleration alpha. Let this be the center C and this be the point of contact O. Now acceleration for any point here on the disk will be given as A, which will be a resultant of the two components of acceleration. One of them is the tangential acceleration AT square plus the centripetal acceleration AC square. So we have the two components here, tangential acceleration AT and the centripetal acceleration AC. Resultant of these two will give us the acceleration at any point on the disk. This is the angular acceleration, while this is the resultant acceleration at any point on the disk. Now this tangential acceleration AT is nothing but the differential of tangential velocity V at any point on the disk, which can be also written as, V can be written as r omega. So this will be d by dt of r omega, and d omega by dt is alpha, that is angular acceleration. So we have r alpha being the tangential acceleration, while centripetal acceleration, by derivation it is being found that centripetal acceleration is r omega square, radius of the roll into angular velocity of the roll square of it. So acceleration at any point on the disk is given as under root r alpha square plus r omega square, square of the term. For the point of contact, however, at O, we see that tangential velocity at this point of contact is 0. Velocity at point of contact O is 0 because there is no slip happening. The disk is under pure rolling. There is no slip happening. So the tangential velocity at point of contact itself will be 0. Not for any other point on the disk, but for the point of contact it will be 0. We can find this out using the instantaneous center or using the tangential velocity definition. Now as tangential velocity at O is 0, its tangential acceleration will also be 0 because it is nothing but the differentiation of tangential velocity. So we see that AT at O is equal to 0. Therefore, while finding out the resultant acceleration at point O, we have under root this value is 0 already plus r omega square, square of the term. This cannot be 0 because the radius of the roll is non-zero. Angular velocity at point O will be the same as the angular velocity of the disk. So both the terms are non-zero, that is why the centripetal acceleration will be non-zero, and therefore we have final acceleration, resultant acceleration at point O is equal to under root of this value gives us r omega square. So although for any point on the disk the resultant acceleration is this, for the point of contact alone we have resultant acceleration to be r omega square. Let's go back and mark the correct option. Option D is the correct one. Magnitude of acceleration of point of contact on the disk is r omega square. To learn about this topic of angular acceleration and tangential acceleration in detail, you can refer to the NPTEL video Dynamics IITM 5.6 Kinematics, Velocity and Acceleration. This is from the course lecture series on Mechanics of Solids by Professor M.S. Sivakumar. He is from Department of Applied Mechanics, IIT Madras. I hope this explanation will help you clear your doubt. Thank you.